Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika, and I'm back with part 2 of lesson 7.5 for all my grade 10 advanced students. So today in this session from lesson 7.5 probability and the multiplication rule, we will do the second part, which will be involving dependent events. So today's learning goal is to apply the multiplication rule to understand involving the dependent event. So let's get started. So in the last video, we have understood what are independent events. The opposite of an independent event is dependent events. So what will happen here? Here, if there are two or more outcomes, the outcome of one event will affect the outcome of other event, and hence the probability will also change. Now, as an example, look at this bag. It has 1, 2, 3, 4, 5 red and 2 blue balls. Now we take a situation, we define the event. Suppose a marble is chosen from the bag and placed on the table. Then another marble is chosen from the bag. The sample space for this experiment, these are the total number of outcomes that are possible. Now, remember when it is a dependent event and we are having some marbles or some different color of balls, then the event is always without replacement. That means once I'm taking a marble or a ball out of the bag, I'm not putting it back. See, it's written here, a marble is chosen from the bag and placed on the table. We are not replacing it back. So in such a case, we will say that the sample space would have get affected. So initially 1, 2, 3, 4, 5, 6, 7. If you see, there are total of 7 possible outcomes. There are total of 7 balls or 7 marbles. It doesn't depend which color we are taking. Now, for example, in this situation, I want to define the event that I want to choose the red marble first, and then I'm not putting it back. It is a question without replacement, and after that the probability is getting affected. How? Let's see. The first time I'm choosing one marble, 1, 2, 3, 4, 5, any of the 5 red balls can come. So 5 is the possible outcomes and total is 7. But now, if I take that red ball and put it on the table, I don't put it back, I don't return it to the bag, then the sample space will reduce. Next time, if one red ball is out, the total sample space or total possible outcome will have only 6 balls. Okay, and if on the second row I also want red again, then what are the options? Out of these 5, already I take out 1 and I don't put it back. So now only 4 are left. So this is how we calculate the probability. And again, for this also, the dependent event, the rule that I use is same. I have used multiplication rule. If you see, to find the probability, I have done the multiplication. I have taken the product. But here what changed? The sample space, because I'm not putting the balls back. Okay. So now I again write for you the formula for multiplication rule of probability, and this time we are doing it for dependent events. So first I will read the probability that two dependent events both occur is the product. We are doing the multiplication of the probability that the first event occurs. That is, if we have two events A and B, and I know that the events are dependent events, the probability of one affects the other, the outcome of one affects the other, and I want to find the probability of A and B. Then that is equal to probability of the first event multiplied by the probability of the second event. And there is a condition. What is the condition? That after the first event has already occurred. So this term, probability B, it's like probability of B over A or probability of B divided A. How do we read this? This term has the name conditional probability that we will discuss more on when we do the 7th lesson of this module. And how do you read it? It is the probability of the second event given that the first event has already occurred, or the probability that the second event occurs after the first event has already occurred. Here A is the first event, B is the second event. Very important. So let's see a solved example number 3 on probability of dependent events from your math book. So the pizza that Jules and Tessie are eating has 10 slices, so total is 10 slices, and it is half cheese and half mushroom. So that means 5 out of 10 is cheese and another 5 out of 10 this is mushroom. It's like 50%. So I'm using for cheese C and I'm using for mushroom capital M. Now Tessie spins the pizza around randomly and selects a slice of mushroom pizza. Now definitely after you take a slice out of the pizza, you eat it and it doesn't come back. So it is a dependent event. The probability will get affected without replacement. Again, then Joe also does the same thing. He spins the pizza and another slice he takes. What is the probability that both of them select mushroom? That means we are interested in mushroom. So the first time, definitely the probability is 5 over 10 because any of the 5 slices of the mushroom can come for the first person, which is Tessa. Uh, then for Joe's, after Tessa has taken one mushroom, one slice is less. So out of 10, only 9 remaining, and one mushroom is already eaten. So out of 5, 4 remaining. So this is your answer. Use the multiplication rule. Take the product. So this is going to be coming out to be 2 by 9. You can simplify 5. This goes 2, 2, this goes this. Yeah, so 2 over 9, that's the fraction. If you want to convert to percentage, multiply by 100, and that's around 22%. That's how you do probability of dependent events using multiplication rule. Okay, so let's do a check question on dependent event from the book. On a math test, 5 out of 20 students got all the questions correct. If 3 students are chosen at random without replacement, so this is your important keyword. If the question says without replacement, you will get to know that it is a question on dependent events. The probability will get affected and you have to apply the multiplication rule. Now what the question is asking, what is the probability that all 3 got the questions correct? Okay, so what is the probability for a correct question? First time. Okay, this is the first time. How many are correct? 5 out of 20. So favorable outcome over total outcome. I'm using the basic definition of probability of an event, which is number of favorable outcomes divided by number of total outcomes. So this is the first time. Now second time when I am taking, now this is without replacement. So the probability for, I'm naming it C1 first time, C2 second time. Okay. Can I say the sample space will reduce because I'm not putting it back. I'm not replacing. It is a question on dependent events. So the sample space reduce. Now out of 5 correct, already one is chosen. So how many left favorable? 4. So both numerator denominator reduce. Now the third time I'm doing this again, my total number of questions reduced by 118 and already 2 correct are taken away, so 3 are left. So these are the 3 individual probabilities. But now we have to use which rule? Multiplication. Yeah, because it is dependent event and we will do conditional probability. So the probability that all 3 got the correct is multiply these 3 numbers, 5 over 20 multiply with 4 over 19 multiply by 3 over 18. So use your calculator, do the multiplication and you will get a simplified fraction. You may also convert to decimal or to percentage. All are going to be the correct answer. So I give you a few minutes. Let's do the multiplication. So 5 multiplied by 4 multiplied by 3 is 60. And now we'll do the denominators. 20 multiplied by 19 multiplied by 18. That's big number 6840. Let's simplify. 0, 0 cancel. So if I reduce and do the simplest fraction, 6 divided by 684. Uh, in the decimal, it is 0.00877. And if I want to convert to percentage, means I multiply by 100. So I shift my decimal by 2 places. Just 1 minute. So I will give you the final answer, 60. Okay, so we multiply by 100, it will become 0.877%. Now, if we want to round off, then approximately we can say it is 0.9%. So this is the final answer. If you check your answer, 0.9%, or if you check the fraction, 1 divided by 114. So this 6 divided by this is equal to 1 over 114. So this is how we solve the question for dependent events using multiplication rule. So that brings us to the end of part 2 of this lesson. Hope you have understood probability of dependent events and you know how to apply the multiplication rule. Stay glued to my channel, like, share and subscribe, because coming up next is part 3 of this video, where I will do the end of the lesson book important questions for practice. So stay connected and all the best for your math exam. Bye students.